Hi everyone and welcome back to my channel. So today we'll be discussing about the adaptive immunity. In adaptive immunity, today we'll be seeing how the B lymphocytes actually work. Okay, so as you know, in lymphocytes there are three types. One is the B cells, another one is the T cells, and then the NK cells, right? So there are three categories. B and T cells participate in the adaptive, okay, and the NK cells work in the innate immunity. Okay, so yeah, what is the most percentage of lymphocytes? If you ask, it is the T lymphocytes, which is about 60 to 70 percentage. Okay, whereas the B cells is 10 to 20 percentage and the NK cells are 5 to 10 percentage, right? Okay, so how is a B lymphocyte actually seen in a peripheral smear? If you see in a peripheral smear, it is known as the small lymphocytes. B and T cells appear as small lymphocytes, whereas the NK cells appear as large granular lymphocytes. It has a cell and a lot of nucleus in it. Okay, there is a lot of nucleus present in it, and it's a comparatively smaller size when compared to a NK cell. Okay, so yeah, in a B lymphocyte there are as you know, in every cell there are receptors. So one of the receptors known as B cell receptors, which can either be an immunoglobulin M or an immunoglobulin D. As you know, IgM and IgD are actually antibodies, right? Antibodies. And these, as you know, antibodies bind with antigens. Whereas, and they have another receptor known as complement receptors. Okay. These complement receptors actually help in recognition of viruses, especially the EB virus. So since these B cell receptors, or else these immunoglobulins which are present in the B cells, they do their function. They go and bind with an antigen actually. So what happens when an antigen and antibody combine together? It causes activation of the complement system. In this case, antigen antibody complex is being formed, right? So it activates the classical pathway in the complement system. Okay, so yeah, so how does actually a B cell work? Let's see. For a B cell to work, the main thing is that this antigen has to combine with the B cell receptor. This receptor may be an immunoglobulin or any other MHC receptor also. So as you know, the standard way how it gets activated or the B cell works is that there's one antigen present outside in the system, and it just comes and attaches itself to the antibody present in it. Okay, this is when this antigen comes and attaches to this antibody, what happens is that B cell becomes activated, and then B cell goes and produces IgM producing plasma cells. As you know, plasma cells are important because they release immunoglobulins, right? Immunoglobulins. Okay, whatever. Immunoglobulins. And these immunoglobulins play a key factor in defeating these antigens or breaking down these antigens and devouring them. So, as you know, there are actually GAMED. So, there are actually 5 classes of immunoglobulins which have specific functions. Right? So, just one type of immunoglobulin won't do because there are a variety of antigens present in our body. So for each one, a specific type of an immunoglobulin works best, is quite efficient, I would say. So for that, Basically B lymphocyte characteristically produces an IgM or immunoglobulin M. Okay, and this immunoglobulin M, as you know, produces memory B cells also, so that it keeps in memory, so that in the future when the same antigen presents itself, oh wait, I have seen you somewhere, I actually defeated you quite some time back, so I know what you're gonna do, and it will go and beat up that antigen with ease, and it will take much lesser duration. Okay, whereas if there's another antigen, so what another antigen which can't actually be defeated by an IgM, what does it do? It has to, improvise. It has to produce something which is more right to fight that opponent, right? For that, the B cell undergoes class switching. It doesn't produce IgM producing plasma cells, it does, but also it produces IgG producing plasma cells, or IgA producing plasma cells, or IgD producing plasma cells, or IgE producing plasma cells, based on the presenting antigen. Okay, so this is, this antigen comes and falls on the antibody receptor of the B lymphocyte. This is just the normal type. There's another way also. You see this is a B cell, right? This B cell has also MHC class receptors. So what happens is that you see these MHC class receptors gets attached to the antigen. Okay, for example, this B cell has MHC class 2 receptors. So as you know, the rule of 8 is that if there's one MHC class receptor 2, then it will present the antigen to the CD4 positive T cell only. Okay, it's actually known as, this is 2, that means this should be 4, so that it comes as 8. If it was an MHC class 1 receptor, then it has to give out the number 8. Okay, so it presents the antigen to the CD8 positive T cell. So this is one rule. It's like a rule. Okay, so since there's MHC class 2 receptor in this B cell, it will present the antigen to the CD4 positive T cell. CD4 positive T cell. Okay, so it presents the antigen to this T cell receptor, and this T cell, as you know, furthermore, it has to reconfirm. Actually, T cells are very cautious. They don't want to make mistakes, so they have another way to ensure that they are not making a mistake. So how does that happen? It occurs by, you see, these B cells have a CD40 receptor. CD40 is cellular differentiation 40 receptor, and the T lymphocyte has a CD40 ligand. Okay, so when these two check out, combine together, then it knows that, okay, I'm doing the right thing, so this will carry out the function, and thereby it will release cytokines which are very toxic to the antigens, and this will go and attack the antigen, and the antigen will be destroyed. And moreover, the B cell, after this confirmation, goes and activates other B cells to come into the action and destroy this thing. Okay, so what happens? This is what happens. Okay, so what happens if during this class switching, the B cell has a defect in it. The B cell is not able to switch classes. Then what happens? Is there increase in immunoglobulin M, or is there decrease in immunoglobulin N, or is there all over decrease of immunoglobulins? As you know, this immunoglobulin is characteristically produced. But since in this particular condition there is requirement of other immunoglobulins, and that is not happening, what happens is that this number of, these immunoglobulin percentages decreases. Okay, decreases. So thereby, to compensate this, immunoglobulin M's are secreted more and more, just to compensate this action, these immunoglobulins action. Immunoglobulin M is produced more, so that it can at least try to compensate its incapability. So that causes increase in immunoglobulin M, which is commonly known as the hyper IgM syndrome. Okay, this is so this is about the B lymphocytes acting during the adaptive immunity. So I hope this video was really useful for you, and thanks for watching. And as always, let me know in the comments how you feel about it. Share it with your friends, and click a like button if you haven't subscribed yet. Make sure that you subscribe, because I'll be letting out really new content and teach you in the most easiest understandable way possible. So thanks for watching, and as always, be awesome.